Alright, 7th grade. Today we're talking about proportions, and this is follows quickly from ratios and unit rates, really just showing that two ratios are equivalent ratios. And we've already done that a little bit by solving or creating unit rates where we made an equivalent ratio where the denominator was 1, but now we're going to talk about using different numbers and just verifying and also solving proportions. So how to create equivalent ratios. When is this relationship the same? So get name, date, title. Here we go. Notes, a proportion is an equation, so it's always got an equal sign, which demonstrates that two ratios or rates are equivalent. So we're trying to show that this relationship we have is the same or is mirrored, or it's a similar relationship between two. In terms of solving proportions or verifying proportions, if they ask us, is having 6 cups of sugar for 2 batches of brownies the same as having 12 cups of sugar for 6 batches of brownies? And that would not be the same. You'd have very, very sugary second batch of brownies or second set of batches. So sometimes they're going to ask us to verify and say, is this a proportion? Using the idea of equivalent fractions is usually the quickest and easiest way. So we can say, well, in that case, and I'll draw you out. I think this is what I said. I think I said is having 2 to 8, 2 cups for 8 batches of brownies the same as having 6 cups for 12 batches of brownies. Is this the same? Is that equivalent? Is that a proportion? Well, we multiplied by 3 on top, and we didn't multiply by 3 on bottom, that's for sure. So these are not a proportion. And so we multiplied by 1.5 on the bottom, by the way, or 3/2. But the idea is we can either solve proportions and find out what would be the appropriate amount of cups of sugar for 12 batches of brownies, or we can verify and see, should we actually be using that equal sign? Is there equivalence? So using equivalent fractions and thinking about multiplying, dividing numerator and denominator by the same number is the easiest way to do it. If you do multiply or divide numerator and denominator by the same number, then you do have equivalent fractions. So you would have an equivalent ratio, or you would have a proportion. But if you can't use equivalent fractions, if it doesn't work out nicely, if in that case, like you didn't know what you were multiplying 8 by to get 12, then what we'll use is the cross your heart method. I'm going to show you in a second why that actually works. But that's just a really memorable way of doing things. The last note is that when you're writing proportions from word problems, there must be symmetry. And that's extremely important, or else you're going to mix up your ratios and you're going to mix up your answers. But let's see why the cross your heart method works. So I stole a little clip from the movie Up, and early on in the movie, she's making him swear to be an adventurer and take her to Paradise Falls, and she goes, "Swear you'll take us. Cross it, your heart. Cross it, cross your heart." And he's like really scared, and he crosses it, and she goes, "Good, you promised. Now no backing out." So she got him hooked. But here's the thing. You need to cross your heart, promise me that you won't think this is just a trick. I don't like teaching methods that you think are just tricks that just work out randomly. All of our mathematical processes make sense, so you need to bear with me for a second. We're going to talk about why crossing your heart makes sense. So the idea here is if we're saying that something like 4/12 is equal to 16 over a number, and if we don't know what that number is, what a lot of people will do if they don't think about the equivalent fraction. So the easiest way to do this is to say, all right, we multiplied the numerator by 4, let's multiply the denominator by 4. If you didn't know it, what a lot of people will do is they'll say, all right, multiply 12 times 16 and multiply 4 times x. So 4x is equal to 12 times 16. And the thing here is that makes sense. And it's a quick way of setting this up. It's going to be a one-step equation once we simplify 12 times 16. But why does that make sense? And the idea is this. We know that whenever we're dividing, and this is division right here because it's the denominator. This is division occurring. So we could undo that by multiplication. Whenever you're dividing, you can get rid of it by multiplying, like I just said. So if we want to get rid of this x in the denominator, we can multiply this side by x. But if I multiply the right side by x, I also have to multiply the left side times x. Of course, they'll cancel over here, and I'll have 4x on the left. Oh, that looks familiar. But what if I don't want this 12 as a denominator either? Then I would multiply both sides by 12 as well. And if I multiply the left side by 12, oh, it's going to cancel. But I also have to multiply the right side times 12. And we'll have 16 times 12. Oh, that looks familiar as well. So let's go through and solve this the rest of the way. 12 times 16, 6 times 2 is 12, and 6 times 1 is 6, plus 1 is 7, placeholder 0, and we have 120. So this is going to give us an answer of 192. So we'll say that 4 times a number is equal to 192. If you were to work that out, oh my goodness, that looks awful. If you were to work that out and divide both sides by 4, just like our equation solving steps, and this is what we'll do when we're solving proportions with this method, you're going to get x is equal to 48. So I say do it all the time because that's 48. Okay, so that's the reason why it works. Let's see actually what it looks like in practice. So this is telling us why cross your heart works. You multiply caddy corner or diagonals, and they must be equal to each other. It's because you're canceling out those denominators by multiplying them to both sides. So let's check it out. First problem says determine if these ratios form a proportion. So what I'm going to say to myself is, okay, so to check this out, I could either find out if they're equivalent fractions, or I could do the cross your heart method and right and left must be equal to each other. So what I'm actually going to say is the easier way to do this is to say I know that 25 goes into 75 like quarters. So I know that 75 divided by 3 is equal to 25. So what we need to do is figure out is 189 divided by 3 equals to 62. If it is, if we divided numerator and denominator by the same number, then we have a proportion. But let's check. 189 divided by 3, is it going to give us 62? 3 goes into 18 6 times. Okay, we're close. 3 goes into 9 3 times. So it's not 62. In fact, it's 63. So these are not a proportion. It's close, but that's not a proportion. So we should write that no proportion. Again, the other way you could do it is you could multiply 189 times 25 and 62 times 75. And if you did that multiplication, got two equal answers, then you would have a proportion. We're not going to do that multiplication because we saw an easier way to do it. And we can also say that we actually already know that it would not be equal. You would not get two equal products because we know that these don't form a proportion. Let's see this one. Solve the following proportion. What if we don't see equivalent fractions? So let's see what the cross your heart method looks like, because I don't know how many times 18 goes into 75. I just can't tell you. So what we're going to do is let's use the cross your heart method here. We'll say, and the reason, I can't believe I didn't even say this yet. It's supposed to look like a heart, if you can see that. This is supposed to be 18 times m, are the two values that were hit here. They're supposed to be equal to 21 times 75. Whoop! 21 times 75. So 18m must be equal to, for these to be in proportion, 21 times 75. So let's get 75 times 21. And I switched them around because of the commutative property of multiplication. 1 times 75 is 75. And I know that 2 times 75 is going to give me 150. 150. So what we have here is 1,575. So 18 times the number is going to give us 1,575. Let's find out what that number is. We'll divide both sides by 18 to figure it out. And m is going to be equal to this quotient. So 1,575. 18 doesn't go into 15. And 18 goes into 180 10 times. So if we did just 9 times, we'd be taking away a group of 18. So it would be 180, but it would be 162. So we need to take away 2 groups of 18, and we need to have 8 groups of 18, not 10. 8 times 8 is 64. 8 times 1 is 8. Plus 6 is 14. We'll subtract, and hopefully you can see that this is going to give us 13. 9 times is 18 going to 135. Well, is 8 times into 144, so we'll need 1 less group of 18. 7 times 8 is 56. Carry a 5. 7 times 1 is 7, plus 5 is 12. Subtract subtract, we'll get 9. And now this is where we have to remember our good old decimal rules. We can fill in the 0 because this is just saying that we have 0 tenths. And how many times does 18 go into 90? And I'm going to guess 5. 5 times 8 is 40. It looks good so far. 5 times 1 is 5, plus 4 is 9. Okay. We got an answer. So you can see that equivalent fractions probably wouldn't have helped us out in this case. But we can use this cross your heart method, and we saw that we get 87 and 5 tenths, or 87 and a half. So that's some work for you. I'm going to leave you with some example problems as always. Oh, no, we have one more. We got to do a word problem. We got to see what it looks like as in a word problem form. So if you scored 270 points after 9 games, how many would you expect to score after 12 games? So 270 points after 9 games equals, and this is what I was talking about earlier when I said there must be symmetry. So symmetry is when something is mirrored to an extent. So on the left hand side we have points to games. I just wrote it in the way it was written, numerator then denominator. That's fine if I write it that way. I could have even switched it. What's important is the symmetry. So when I move to the right side, if I have games on the bottom on the left, I need games on the bottom on the right. So we'll say 12 games on bottom. And the thing is, we would not get the right answer if we had to put games on top. So we'll say we used M last time. Why not M again? M points. So we're going to try and find out how many points we would have. So here we go. You might see something that looks nice with 270 over 9. You could find points per game and then multiply it up times 12. But we're going to use cross our heart to check it out again. So 9 times M is 9M. 12 times 270, let's just save some space and do it right away. So 270. And this is writing poorly, I'm sorry. 270 times 12, 2 times 0, 2 times 7 is 14, 2 times 2 is 4, plus 1 is 5. And then we're just going to multiply it all by 1. So it would be 270 with that placeholder 0. This is writing super poorly. 4, 12, 3,240. 3,240 has to be equal to 9M. Let's divide both sides by 9. And what are we going to get? We're going to get M, or the number of points is going to be equal to 3,240 divided by 9. 9 goes into 32 3 times. And that's 27. Subtract. And we will get, 5, 54. 9 goes into 54 6 times. The important thing here is that you realize that we're only in the tens place. So you need to factor in this last 0. The decimal is over here, so we need to put that 0. So after 12 games, you would expect me to have not 36 points, but 360 points. So there you go. There's another example. We've shown the symmetry. We've used equivalent fractions, but we've also used cross your heart, and we know why it works. Let me show you where we got that number. We multiplied 12 times 270. So cross your heart's going to work out. Equivalent fractions are going to work out. We just got to find the right time to use either. And I'm going to give you the opportunity to do it on your own with these last ones. Number 1 says solve the following proportion. 24 30-seconds is the same as G over 44. What must G be? And the second one says if 3 cups of sugar make 36 brownies, how many brownies does 5 cups make? So set up a proportion, solve it whatever way you see fit, and I'll catch you tomorrow.